Hello, now we are going to have a quick revision of all the subjects that we have seen so far. Now, we have seen this SPSS program, what it is about. We have seen that there is a data view and there is a variable view here, and in this variable view, we define variables. And the first thing that we have learned was there shouldn't be a space between the variable names. For example, if you want to write here first name, you cannot write a variable name like this. It says it contains an illegal character. So empty spaces or question marks are not allowed in this program. So any measurements or any number, for example, let us say number of problem teeth, number of, you cannot write it like the an illegal character. How you are going to write it? This is the first thing that we have learned. In the variable names, you shouldn't have any space in between. Okay, you shouldn't have any space in between. This is the first thing. And type. Okay, we have numeric type. We have string type. With the numeric type, we define the width and decimal spaces. What is the width of this numeric? How many digital points that we have. Here label is we write what it is about. You can write anything in the label part. Values, if we group it, for example, if we have a variable name like gender, value part helps us to group it. For example, one female, second male. We say that it's not important whether we write one for the male, two for the female. There is no order for that, and the decimals should be 0 because when we are grouping, we don't need these 2 digital points here. And the width, of course, gender can be female, male, or maybe some other types, but it's only 1 digit number, 1. Okay, we only write here 2 groups. It depends on your measurement, on your study, how many groups that you define here. Measure can be here, since it is group, either it is ordinal or nominal. If the order matters, if the order is important, then it is ordinal. If the order doesn't matter, then it is nominal here. Okay, so the order is not important, therefore it is nominal. And when the order is important, for example, let us recall when we write, for example, school or the education. Okay, so here again we can have 0 and width. Okay, it's 1 digit here again. Name, what is your education? Okay, we write here. You can write anything. It's not important whether you have complete question here or you just write education. It's all okay. And here values, you can group this education. 1, primary school. It's not important that you have a space here. This is not a variable name, so you can have spaces in the labels. 2, we have a secondary school. And 3, we have high school. It depends on our research study whether we have 4 as a master's degree or more bachelor's degree, or we have PhD. So it depends on our study group, on our participants. If we don't have any participants or any patients with master's degree, then we don't include it, or PhD degree. Yes. We add it first of all. Okay, so what we have done, we have grouped it, and the order is important here. Whether it is primary school, secondary school, you cannot finish, for example, primary school and go to master's degree. First of all, you have to have primary school diploma, and the same for secondary school. You have to have secondary school diploma. Okay, it's and here the order is important here. Now, since the order is important, we say it is ordinal. Okay, the order is important. We say it is ordinal. Good. So we have nominal, we have ordinal, and we have seen that here with and decimals should be 1 and 0. Now this is variable view, where we define our variables. In data view, we write our data. The first here, the number 1 here means first participant in our research study. Second participant. Third participant. Fourth participant. Or if we are talking about our patients, then first patient, second patient, third patient. Or if we are talking about our doctors, first doctor, second doctor, third doctor, fourth doctor, so these are just number of participants in our study. So each row represents a participant. So this is just an example. I write 1, 1 here, I write 2, 3 here. This is just an example. Of course, you have to ask 2 people or you have to look what their gender is and what is their education level. By the way, gender is just 1 and 2 here, so I can only write 1 and 2. I didn't write any genders, other genders here. Now, if I write like this, we have seen that these are just group labels. Okay, this means group 1. This means group 2, group 1, group 1, group 2. And here in the education, this is 1. This is 3, 5, 6, 1. Okay, so these are just numbers here. And if you click here, you see what it is it contains. So this is SPSS. SPSS is for doing statistics. It helps us to find frequencies, percentages, create tables, to analyze data. First of all, what I have said was to find frequencies, percentages, cross subs. These are descriptive data. In biostatistics, what is important is describing data. First of all, we have to describe what we have at our hand. What is the case? What is the current situation? This is the first thing for improving, for dealing with our patients. So what is our patient's case? How many patients we have used this medicine, or how many patients, what are their other statistics, how many patients are female, male, or even how many patients have cholesterol, or how many patients are going to clinic A, how many patients are going to clinic B. Okay, this kind of information are all important. And these are descriptive statistics, describing our data. And the second thing is comparing. Okay, so if we compare means, this is parametric tests. We have learned that these are powerful tests, and we want to deliver this type of test. And if this type of tests are delivered in studies, they are good. Okay, and we talk about what kind of studies, what kind of research studies we can trust. There are many studies on internet, in books, many information, lots of information. We discussed that we can trust some of them, we can question some of them, and we shouldn't accept some results of some statistics. Which ones we shouldn't accept? If there's not much information. If there is not much information about how, out of how many people that it is found. Okay, this is really important. If you deliver a research study with 5 people and if you deliver a research study with 500 people, of course the results are different. So the number of participants is important in a research study. Second thing, okay, the more participants that we have in a study, the more that we can trust it. Okay, because people are different, their situations are different, there are different cases, and so we will be able to consider different situations. The variety of these participants is the second important thing. Okay, if we have 500 patients from a specific city or from a specific country, okay, maybe that their habits of life are different than the other people, and maybe that the other people are using some special diets, and in their diets the kind of food that they are eating may have reaction with our medicine and may be allergic to them. Okay, so it's really important to have a research study not in a country, not in a city. If we are talking about different countries, so it's important to deliver a specific study in a different country. So you may see this kind of studies on internet. A research study is delivered in Cyprus, a research study delivered in Turkey. So the first thing, the number of people is important. How many participants? Second thing, in which country? Okay. So if we find a result in Cyprus, we can only talk about Cyprus people. Okay. If we find a result in Turkey, we can only talk about Turkey. It's a big country, by the way. It's not easy to talk about all the cities. You know that the climate difference. Some people are used to live in very cold weather and have a strong body for cold weather. Okay, they don't find it hard to live in cold degrees, and some people are just cannot tolerate or have problems. Okay, so yes, compare means is for parametric tests, and we have non-parametric tests. What are these non-parametric tests? Yes, hello, I start again recording. Yes, what I was talking was parametric tests. There are some parametric tests which we compare means. I'm going to take some notes here. So parametric test works with mean, and they are more powerful tests. They work with mean. And what is mean? It's arithmetic mean. We have 3 different kinds of mean, by the way. We have 3 different kinds of mean. Kinds of mean. And with this, there is mean. Yes, here there are 3 different kinds of mean. Mean, median, and mode. There are different kinds of mean. And when these 3 of them are equal, we say normal distribution. And in this normal distribution, we use parametric tests. In this parametric test, these are work with mean. They are more strong tests. These are more strong tests. Strong tests. Okay. And some examples of these parametric tests are t-tests. Okay, we have 3 types of t-tests. We have discussed what are these 3 tests and what are their preconditions. And there is ANOVA. Okay, so in this parametric test, we have seen that there is one-way ANOVA here, and as test independent sample t-test, independent sample t-test, one sample t-test, and pair sample t-test. Okay, we have three different types of tests. We see here. Okay. And ANOVA, we have seen that there is one-way ANOVA. There are different ANOVAs, but we have seen this one. We are going to see other types later in other courses next semester. One-way ANOVA. Yes. Okay, so all these three requires, and this one requires normal distribution. And we have seen that we have to have at least 30 participants. 30, okay, not 13, 30 participants here. And we have to have equal number, nearly equal number of groups. Okay, independent sample t-test has two independent groups. And we have to have equal number, nearly, one of them can be 32, the other one can be 30. One of them can be 100, the other one can be 101, 102, nearly equal, but one of them cannot be 100 and the other one 150. This test doesn't work for that kind of difference. Little difference, okay, they give, and there's something else which is really important for this SPSS and all the other statistical programs, they always give you some results. Okay? Whether it is true or false, that's why that we have many mistakes on research studies, because if you write, describe, compare means one sample t-test, and if you pass these values and continue, you will see that you will have a result. Okay, and if you don't have prerequisite conditions, right, if you cannot use a test, and if you use that test when you are not allowed to use, when it's not right to use, you will have a result, and maybe that you will interpret the result wrong. So what is important here is that we have to know which tests we can use. We cannot use all tests in all conditions. Okay, if we have two dependent samples, what I mean, if I have a measurement in January and if I have second measurement in March, okay, this is a repeated measurement. If it is a repeated measurement, I cannot use independent sample t-test, because what I have in repeated measurement is I have two dependent cases, two dependent results. Okay, people blood test results in January depends on people's blood test, the same people's blood test on March. Okay, it's the same people and it's blood tests. So we can use some medicine or maybe that an operation passes in between, but there's a change. Okay, so we have to interpret the change, but we say it's dependent. Or if we have a midterm mark and if we have a final mark, okay, of a course, these are dependent. It's the same course. If you have high midterm marks, then you may be more lucky in the final exam. You will find it a little bit more easier. Okay, so we say they are dependent. Or if you we have Biostatistics 1 this year and Biostatistics 2 second semester, then these two courses are dependent. Okay, if you pass Biostatistics 1, then you will find Biostatistics 2 easier because you will understand the basic concepts. So if you have two dependent groups, you have to use paired sample t-tests, okay, if they are dependent. But if they are not dependent, you are going to use independent sample t-tests here. Okay, independent sample t-tests, paired sample t-tests. So it's important. These are just program. Okay, when you do wrong, they don't tell you. They don't. It's not artificial intelligence. They don't have artificial intelligence, this kind of SPSS programs. When you are doing wrong, it doesn't give you warning messages. Okay, wrong, these are dependent groups, you are doing wrong. No, they don't give you such messages, okay? You have to know, you have to decide, human beings have to decide whether these groups are dependent or not, okay? For example, what is independent? Independent are female and male, two different groups. These are independent. Two different cities, Nicosia and Famagusta. These are independent, two different cities. Or two different medicines, okay? This is medicine 1, this is medicine 2. They are independent. They are not same medicine, different medicine. Two different toothpaste, Signal or Colgate. They are different, so they are independent. Okay, these are important. And if you have one sample, okay, and you want to decide whether it is above a measurement specific degree or below, then you have to use one sample t-test. One sample t-test is used when, let us say, cholesterol level of your patients is, you have a specific degree, it may differ according to the liquid for measurement that you use. Let us say 190, okay? If it is above 190 or below 190, so you may have a general idea. If you have 500 patients, let us say, and if you have one variable, cholesterol level, and you want to compare it with a specific number, okay? You don't compare two variables. You don't have two different variables. You don't have two different measurements. Just one measurement, and you want to compare it with a specific number. Then you use one sample t-test. And we also have here one-way ANOVA compare means. We have seen these ones. And this is for 3 or more groups, okay? If you are going to compare, let us say, 4 different, you have a different study, okay? You are going to different groups, gender in more than 2 groups, let us say, female, male, lesbians, and the other group, okay? Let us say 3 groups. You are going to compare these 3 groups. It's about health. There are maybe different studies, okay? Then what you have, since it's more than 2, okay, you have to use one-way ANOVA, okay? If you group it more than 2, then you are going to use one-way ANOVA. If you are going to group it in 2, then you use independent sample test, okay? One-way ANOVA is also independent. If you are going to use, let us say, 3 countries, okay? Turkey, England, and Cyprus. 3 different countries, or maybe 4. Okay. Then you use one-way ANOVA. If you are going to compare 3 different medicines or 4 different medicines, then you are going to use one-way ANOVA. Yes. So these are compare means, and these are parametric tests. If distributions are normal, for example, we were talking about cholesterol level. If cholesterol level graph, if we draw a graph and we see that it's normal, it's symmetric, okay, then we are going to use these ones. If distributions are not normal, if you have less than 30 participants, if the groups are not nearly equal, one of them is 100, one of them is 150, okay, so in such cases, we are going to use non-parametric tests, okay? And these are less powerful, but we have to use them sometimes to have some idea about the situation if we don't have any other choice for using parametric tests. If they don't satisfy the conditions, then we are going to use non-parametric tests. In this test, here, these are the tests, okay? There are different tests. We have seen that there is binomial test, Kruskal-Wallis test, Mann-Whitney test. We have seen 3 of them for this semester. but there are many others, okay? It's not just that. I'm going to mention other ones. You have to know just there is two different tests. This compare means and this compare non-parametric test compare medians, okay? They compare, this is the difference. So here non-parametric test, metric test are less powerful tests. We apply them when the conditions doesn't satisfy, less powerful, and they work with median. Okay. Yes, and now we have seen that it's important to know preconditions for not doing wrong. From here. Yes, so let us talk about hypotheses. Hypotheses are important. Hypotheses are the idea that we have at the beginning. So hypotheses. These are the idea in researcher's mind at the beginning. Ideas in researcher's mind at the beginning. Okay, these are ideas at the beginning, and H0 is zero hypothesis and null hypothesis. We can say null hypothesis. It's zero hypothesis. Okay, and H1 is research hypothesis. So this is the idea in our mind that the result will be. Okay, we think that H1 will be true. So therefore we say research hypothesis. And H0 always says there is no difference. Okay, so therefore we say it is no difference hypothesis sometimes. Okay, so it says there is no difference between, let us say, there is no difference between female and male blood test results. Okay, this says no difference. So when you have no difference, it's H0. Okay, this is H0. This is no difference. And when you have this is H1 is there is significant difference. Okay, this is just opposite of this H0. So H1 always says there is difference. Okay, there is significant difference. So why significant? Why is the word significant? Because we have applied some tests and we have found as a result of this test that there is significant difference. So it means this. And now, yes, the first thing in a research study is writing hypothesis, and after that we deliver some tests and we reach to some decisions. Okay, the researchers reach to some decisions, and in research papers we read these decisions. We see that okay, it should accept H0. Okay, but it rejects. It should accept H0, but it rejects. This is type 2 error. Or if it should reject H0 and it accepts, this is type 1 error. So here there may be some errors. So when we accept H0 and when we reject X0, when we accept H0, we accept H0 when there is no difference. Okay, and okay, how we understand that there is no difference? This is important. How we understand when there is no difference, or we say that when p-value, okay, when what is this p-value? P-value is a value that we have as a result of this test. T-test or ANOVA or other binomial Kruskal-Wallis test, we have a p-value. And in this p-value, we reach to a condition that it is bigger than 0.05, okay? If for 95 confidence interval. This means confidence interval. Or when we reach to condition that this p-value as a result of this test is bigger than 0.01, in the 99 confidence interval, then we say that there is no difference, okay? If it is smaller than these values, then we say there is difference. Okay, so when this is the case, we say there is no difference and we accept H0. But in the research paper, if it says, okay, P is bigger than 0.01 and we reject H0, then this means that there is a mistake, okay? And when we have to accept and when we reject it, then this is type 2 error. Yes, that's accepting, rejecting, and errors in biostatistics. We have to know that there may be, okay, it's not always, there may be some errors around, and we have to learn to question everything. We shouldn't directly believe them, okay? So if someone says that medicine 1 works perfectly well, okay, what does perfectly well means? You say it works. Where did you try it? With how many patients it worked? What are your tests for that? Okay, so you have to learn questioning.